Welcome to Cardinal Views, highlighting the people and programs of Lamar University. I'm Leah, a communication major.
And I'm Thaddeus, also a communication major. Today we'll explain how Lamar is expanding its reach with science activities for area elementary and middle schools, and new online education options for all ages.
And we'll show you some of the exciting innovations in fuel cell research taking place on campus, from advanced technology in the Smart Energy Systems Laboratory aimed at strengthening military capabilities to undergraduate engineering students building a fuel cell car.
This ultralight car is built of carbon fiber and powered by a hydrogen fuel cell. It serves as the senior design project for 9 Lamar mechanical engineering students, and as Lamar's entry in the Shell Eco Marathon competition.
In this car, the top speed that we actually got was 22 miles per hour. So it runs pretty fast. I mean, I tried to keep up with it when I was running right next to it, but it blew me away after a while. I got tired.
Speed is not the main goal for this race, though. For the Shell Eco Marathon, these Lamar mechanical engineering students are trying to build the most fuel-efficient car they can imagine.
The biggest thing that I think makes our car competitive is that we're using carbon fiber, and it makes it very light. Carbon fiber is a lightweight material. A lot of teams there are using aluminum tubing, and our car should be approximately 50 to 60 pounds lighter than an aluminum tubing frame.
The vehicle's fuel source also is innovative, a 1,000-watt hydrogen fuel cell.
Our car is going to be powered off of a hydrogen fuel cell, which is a very complicated system that basically you put hydrogen in and it mixes with oxygen to produce electricity, and that electricity powers our direct drive rear motor that we have mounted on our back tire.
The lightweight car should require very little hydrogen to complete the 6-mile competition course in downtown Houston.
The most important aspect about this vehicle is by far the body itself. I mean, the carbon fiber, you can do virtually anything with this material if it's braced up properly. And I think that's, between that and the fuel cell, I think are certainly one of our most important attributes for this car.
The team first had to create a custom mold in order to build the one-of-a-kind carbon fiber body for the car. Members are thankful for the help of experts from the civil engineering department and of a prominent Lamar alumnus along the way.
Andy Green is a pioneering composites guru, essentially. He started out with a Chaparral car in Le Mans. He took it over to Le Mans. It became the first fully composite car. He is also a former Lamar grad and has been our essential technical info point of contact for this vehicle.
Even with expert advice, challenges are bound to arise.
Most teams that have done this before have a pretty good idea of how they want their car to look, whereas we essentially had a driver and designed a car around a driver as opposed to having a design concept.
The biggest challenges that we face, other than time constraints on this, is that just some of the designs that we came up with when we actually started trying to produce those designs didn't work out the way we had drawn them up on the chalkboard.
Time and money has been a big challenge for us. Trying to get all the funds in order to get this project started has been a big challenge for us, and also starting pretty late, getting this project done, we're running out of time, so that's a big challenge as well.
Some of the concerns with the wheel is that the wheels are too small, and so we need a bigger diameter wheels in order for the shell not to hit the floor, because we're scraping and that just takes a lot. That pretty much like breaks on the car, and that's not what we want in the race. We want to keep on going and just cruise all the way to the finish line maybe.
The idea behind senior design projects is to allow engineering students to apply their knowledge by overcoming real-world challenges like these.
It's difficult for them because this is the first time that they actually design and build the system that in their 4 years of studies here, but they realize that this is the ultimate engineering experience because they have to devote their time and the energy and the knowledge in order to make it happen. But once it's come to fruition, then they will realize that this is what engineering is about.
Month after month, week after week, team members keep solving problems and continue learning from the experience.
What I've learned from this project is being able to work with a group of guys great group of guys and be able to communicate with each other. My communication skills have greatly improved through this project.
Learn how to make carbon fiber molds. I can tell you that. I wouldn't say I'm an expert, but I'm getting on the verge. I'm pretty sure I can make anything out of it now with the right timing and money.
The project tests all of their knowledge and skills.
A lot of our engineering background has come into this, everything from mechanical design and stresses and fractures and all. I think it's all tied in very well with our project.
Their work pays off with a car built not for luxury, but for efficiency.
Well, in the car, it is on a hot day, it's going to be very warm, and I am going to be sweating, especially with a helmet. And it's very uncomfortable. It shakes because we don't have shocks or anything, so it's a really rough ride, and, well, it's going to be a very uncomfortable ride.
Adding a more comfortable seat is not an option. The driver needs enough clearance to turn his head while wearing a helmet. This lean machine has none to spare.
I could compare it to like a go-kart, in a sense. The car kind of rides like a go-kart. It's rough, except the go-karts have nicer seats.
The driver's helmet is equipped with a wireless device so team members can communicate during the race. He uses a thumb accelerator like a motorcycle's and hand brakes like a bicycle's, with the goal of maintaining an average speed of 15 miles per hour.
In a sense, it's kind of like a car. It has a cruise control, it has the horns. The only thing that it doesn't have is just the lights and the brake lights and things like that. But other than that, it's kind of like a car except for the comfort features.
The team's faculty advisor believes Lamar can be proud of the car these students created.
In terms of the working ethics and the unique features of that, this is one of a kind that's come out of the senior design project in the mechanical engineering department.
As the car nears completion, team members expect the project to help them moving forward from their engineering education into the professional world.
If anything else, be attention to detail, because if you miss a minuscule little detail, that's all it takes is one small detail, and next thing you know, your car's sitting buckled in the middle of the road and people are laughing at you. And I don't want to embarrass this university or our group or myself for that matter.
They also leave for the competition in Houston expecting a good experience.
I expect us to have fun and enjoy what we have done, be proud of what we have done and all this time we spent on this project, and just to win. We want to win, so we're going to win.
The Lamar team places third in its category and 10th overall out of more than 40 teams at the Shell Eco Marathon. A last-minute change to a lighter driver, the girlfriend of a team member, helps Lamar achieve the equivalent of 1,215 miles per gallon. Students also have plenty of suggestions to help next year's team do even better.
Coming up on Cardinal Views, take a behind-the-scenes tour of Lamar's Smart Energy Systems Laboratory. And we'll talk to Dr. Paula Nichols about how high school students can get a head start on college for free. Stay tuned for more Cardinal Views.